Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're doing lesson 103 in addition 2, and lesson 102 in addition 3 of your Saxon Blue Book. And the title of the lesson is Terms, Adding Like Terms, Part 2. So we know already from part 1 that terms are separated by plus and minus signs. And when we have one like this, we have a lot of different terms, but can we combine some of those terms to make this a shorter statement? So we have an X and an X, so we'll make a little squiggle under the X's. And we have a Y and a Y term. And then don't we have two constant terms? So we do have two of each type of term here. So we can add the two X terms together. X is the same as 1X plus 3X's is 4X. So we have 4X, and that's going to take care of the X terms. And then we have a 2Y plus a negative 7Y is a negative 5Y. So that takes care of the Y terms. And then a 5 and a negative 2 are both constant terms. So 5 plus a negative 2 is a plus 3. And the whole thing could be, my kitty cats are in there and they're not being very nice to each other. Stop. They're being mean to each other. So 4X minus 5Y plus 3. Okay, so that is the simplified equation where we have already added like terms. Now, let's look at these two terms down here at the bottom. We have a 4XY and a 6YX. Now, an important thing to remember is that order does not matter. The order of the variables does not matter. The X and Y are multiplied together. The Y and the X are multiplied together. Multiplication is commutative. We're going to get the same thing whether we say 4XY or 4YX. It's the same. Therefore, these are like terms. Okay, so here we have 4XY and 6YX again, and we're looking at these. We're going to look at just the XY and the YX to see and convince ourselves that they are the same. In order to convince ourselves that they are the same, we're going to substitute into each one of these expressions. X is negative 2 and Y is 3. So if I have X, Y, then since X is negative 2 and Y is 3, I'm going to put the negative 2 first and then the 3, and negative 2 times 3 is a negative 6. Okay, so we'll make this one come over here. And then we're going to do the same for the YX here. So the Y goes first, so we're going to have a 3 times a negative 2, and again, that is a negative 6. So we had a negative 6 and a negative 6, and the order did not matter, not even a little bit. So we can, with confidence, say that 4XY and 6YX are the same, and since they are the same like terms, then we can just add their coefficients together, and then we have to pick either XY or YX, but since XY is alphabetical, we'll just say 10XY is the sum of the two. Because they're like terms, we can just add them together. Okay, so for our next example, we have the question, are 2XY squared and 3Y squared X and 7YXY all like terms? Okay, so when we're looking for like terms, we're not looking at the coefficient at all. That is not important. When we're deciding like terms, we're trying to say, do we have the same variables raised to the same power? Okay, so in the first one, we have 1X, and then we have a Y times a Y. In the second one, we have a Y times a Y, and then we have the 1X, and we've already decided that order doesn't matter. And in the last one, we've got a Y times a Y times the 1x. So yes, they are all the same like terms. The order does not matter. Now this one is not simplified. These two would be simplified, but this one is not simplified because I have a y times a y, which could be more simply expressed as y squared. But they are like terms. Okay, on this one, it was so long that I had to drop down and write the +2 below. It was such a long one. So we're looking for like terms. We have x's, we have two x's, and then we have a xy and a yx. So those would be the same like term. And then we have a 3 constant, constant, constant. So I like to put a little different symbol under each one. Okay, so now let's add all of our x's together, and we're going to get a 10x. So we can cross those out. We have a 2xy and a 3yx. So they're like terms. Order does not matter. So we're going to get a 2 plus 3 is 5xy. So we can cross out those two. And lastly, 3 plus 4 plus 2 is 7 plus 2 is 9. And now we have it simplified. All right, we have another problem here, our last example. 4 plus 3x squared plus 2x times x plus 4x plus 7 plus 3x. Wow, that's a mouthful. Let's see if we can simplify it a little bit. So we have a constant and a constant. We have an x squared, and this one has an x times an x, so that's an x squared. And then we have an x and an x. So we have 3 different types of terms. So let's add our x squareds first, because we would normally go descending order of the variable. And that means we're going to take the highest powers first and then move down. So we've got 2 that are the like terms with x squared. So 3 plus 2 is 5x squared. And then we have a 4x and a 3x, which is a 7x. And we have a 4 plus a 7 is an 11. And there we have our last example, and now it's time for our practices. Okay, this is practice A, so I want you to copy it down and pause your video. Now, this one's a little harder. There's a lot of X's and there's a lot of Y's. So go off and see if you can do it, and then come back and check and see if you did it right. So pause your video. Hopefully you did that. So now this one has a y, y, x. 2 y's and an x. So let's see if we can find another one that has 2 y's and an x. Y squared is 2 y's and an x. Y squared, 2 y's and an x. So we have 3 terms that are like, but look at this one. This is 2 x's and a y. So it's a kind of sneaky difference, isn't there? So we have 3 that are like terms and 1 that stands alone. So let's take our 3 like terms first. So we've got an xy squared, xy squared, xy squared. So 3 plus a -6 plus a 3. Yeah, that was a plus sign and that was a minus sign. I kind of wrote over it with my circles there. So 3 plus a -6 is a -3 plus 3 goes to 0. Let's check that. 3 plus a -6 is a -3 plus a 3 is 0. Guess what? Those 3 all cancel each other out. So now we just have this one, 2x squared y, because I have the 2x terms and then the lonely y. So my answer boils down to just one term. Here are our last two examples, so copy them down and then go off and try to do them by yourself. So pause your video. All right, let's look at the first one and see how many of them are actually like terms. We have an xxx, so that's the same thing as an x cubed. Here we have an x squared times another x, which is the same as an x cubed. Here we have an x cubed, so that's the same as an x cubed. But now notice that over here we have an xy and a yx. So these, we'll make those black. Those are different, aren't they? So when we're going to put it all together, we would take all of our squiggle blues, since we have declared them all to be x cubes, and since this is just a 1 in the front, we have 1 plus 3 is 4, plus 4 more is 8. So we have 8x cubed. So we'll just write down here 8x cubed, and that takes care of all of those. And then we have a xy and a yx, which are also like terms. So 2 plus a negative 3 is a negative 1 xy. So we'll put negative 1 xy, and we are done. Now, do you have to have the 1 there? You have to have a negative there, but you don't have to have the 1 there. You could just leave it like that, and it would be just as correct because the 1 is understood. But the sign is very important, isn't it? Now, we look over here. This one is a y cubed x. Uh-oh. This one's not a y cubed x. This one's not a y cubed x. So they're not all the same. This one is an x squared y squared. And this one is an x cubed y. We have no like terms. So all we can do is get them in the best and simplest form we can. So this one, since we have a y squared and another y, we can make that a y cubed. So let's make this a 1xy cubed plus a 1x squared y squared minus a 5x cubed y. Okay, so we just made this one simpler by joining our two y's together. Our y squared and our y becomes the y cubed. We made this one easier by making the y times the y a y squared. And we just copied this one down exactly as it is. And we are done. This is the answer. And we could just do that, couldn't we? Either way is correct. So that is the end of your lesson 103 or 102, depending on which book you are using. And this is Mrs. A, and may God bless your day.